There are 5 major factors that control the formation of soils: parent materials, the geological or organic precursors to the soil; biota, which includes vegetation, microbes, animals, and humans; topography, the slope, aspect, and landscape position; time, the period of time since the parent materials became exposed to soil formation; and climate, primarily precipitation and temperature. We'll be focusing on climate and how precipitation affects soil formation. Precipitation is an especially influential process in parent material weathering and translocation. The amount of water leaching through a soil is determined not only by the total annual precipitation, but also by at least 4 other factors: temperature and evaporation, permeability, topography, and seasonal distribution. To illustrate these 4 factors, we'll compare them to a party. In a hot climate, evaporation from soils and vegetation is much higher than in a cool climate. A higher rate of evaporation means less water is available for percolation and leaching in the soil. Therefore, a cooler climate with the same amount of rainfall as a warmer climate is expected to have more profile development. Like making pasta salad for guests, the pot of water placed on a burner set to high will boil and evaporate faster than the pot of water placed on the cooler, low burner. The hotter burner represents a warmer climate and more evaporation, and accordingly, less profile development. Another influential factor in precipitation soil formation is permeability. The black checkers represent a compacted clayey soil. The red checkers, representing rainfall, are unable to infiltrate the tightly packed colloids. Another game reveals a more spaced out distribution of black checkers. The spaces provide enough room for the red checkers to penetrate the opponent's side. The more pore space available, like those found in coarse sandy soils, allows more water to infiltrate and thus more rapid soil development. Water falling on a steep slope will run downhill so rapidly that only a small portion will enter the soil. The top and bottom of the hill, on the other hand, will experience more percolation and leaching than the slope. The bottom of the slope will receive the greatest effective rainfall because, in addition to direct rainfall, it will collect the runoff from the adjacent sloping side. In our scenario, the bowl of popcorn represents rainfall, and the 3 guests represent a steep hill. As the first guest, representing the top of the hill, enjoys a handful of popcorn, she quickly passes it to the middle guest, representing the slope. The middle guest barely has enough time to grab the popcorn before the third guest, representing the bottom of the hill and the region of precipitation accumulation, takes the bowl and eats the rest of the popcorn. Next, let's consider a site that receives an average of 600 milliliters of rainfall per year. The 600 milliliters of rainfall distributed evenly throughout the year, 50 milliliters per month, is likely to cause less soil leaching and erosion than the same amount of rain falling a rate of 100 milliliters per month in a 6-month rainy season due to soil pore saturation. The full cup represents a concentrated rainy season, while the nearly empty cup represents an even distribution of rainfall. The full drink completely saturates the towel, leaving it dripping with excess liquid. The nearly empty drink cleans up easily, illustrating the point that the soil, represented here by the towel, readily absorbs all the liquid and therefore little leaching will be seen. To review, precipitation is an especially influential process in parent material weathering and translocation. The amount of water leaching through a soil is determined not only by the total annual precipitation, but also by temperature and evaporation. A cooler climate with the same amount of rainfall as a warmer climate is expected to have more profile development. Permeability. More rain water will infiltrate the leach through a coarse sandy profile than a compacted clay one. Topography. Effective rainfall is greater on a level site than on a slope. The level site, especially the bottom of a hill, will experience the most percolation and leaching. And finally, seasonal distribution. The same amount of rainfall distributed evenly throughout the year is likely to cause less erosion and leaching than receiving an equal amount of rainfall over a 6-month period. These 4 factors interact to determine how effectively precipitation can influence soil formation.